Today I'm here to show you the Zynq-7000 All Programmable SoC AD9361 Software-Defined Radio Systems Development Kit and highlight its key features. This kit provides a development platform that can be used to evaluate, prototype, and accelerate the development of cognitive radio and small cell wireless applications on the Zynq-7000 All Programmable SoC family of devices and the analog devices AD9361 Agile RF transceiver. Zynq provides the ideal processing platform for cognitive radio applications that demand higher levels of performance than what can be achieved with an off-the-shelf DSP. This kit includes the Xilinx ZC706 development board that includes the Zynq-7045 device. There's 2 HPC expansion slots, Ethernet, USB, and UART interfaces, and 1 gigabit of DDR3 board memory. The Zynq-7045 device includes a 1 GHz ARM dual-core Cortex-A9 processing system combined with 350,000 logic cells and 900 DSP48E1 slices of programmable logic. These devices use a 28-nanometer HPL process that yields up to a 50% power reduction over previous generations of programmable logic. And high-throughput AMBA4 AXI interconnect provides over 3,000 direct connections between the processing system and the programmable logic that eliminates system bandwidth commonly associated with multi-device processing platforms. This kit also includes the analog devices FM Comms S3 FMC card that features the AD9361 Agile RF transceiver chip. This device supports 2 channels of RF transmit and receive, and it can be configured as either a single channel 1x1 or MIMO 2x2. This RF interface supports a side tuning range of 70 MHz to 6 GHz. And the AD9361 is a highly configurable device and also includes a programming interpolation and decimation filtering. The reference design includes a Linux driver file that allows users to easily tune the parameters of the transmit and receive chains from software. This kit also includes a reference design that interfaces the analog device's FMC Comms S3 card to the Zynq programmable logic using an LVDS parallel interface. 4 pulse 4G LT antennas are provided to transmit and receive the RF signals, and Linux is running on the ARM processing system that includes a driver file that lets users, again, easily interact with the FMC Comms S3 FMC to easily set the transmit and receive channel parameters, select between several test waveforms, and visualize the input data in either the time or frequency domain or in a constellation plot. Shown here is a block diagram of the reference design. This design was created using Vivado Design Suite. An input test pattern is generated by a DDS block and sent to the FMC card transmit channel, where it goes through the DAC and the modulator. The signal is then looped back into the receive channel, where it goes into the demodulator and into the ADC and then into the Zynq device through the LVDS interface. The AXI DMA core is used to send the input data into the Zynq ARM processing system, where it can then be displayed through the user interface. The design is now running, and we can now view the results using the ADI-IO Linux scope. The scope supports plotting of the captured data in 3 different modes. So here's actually the frequency domain view. And I can also show the data in the time domain view, which in this case is somewhat scattered. And then it will also display the data in a constellation view. And the application also allows users to program the parameters of the FMC card as well. So shown here, this tab allows me to interact with the design and to reset parameters. So I can make a simple change here, like I'm going to change the sampling rate of the filter chain, and I'll change this up to, say 80 megasamples per second. And then I can start the capture, and let me put this if I put this back into the frequency domain, I can start the capture, and what we can see here is that the noise floor has actually dropped from 80 dB down to minus 90 dB. Again, this interface does allow you to quickly interact with the design and the FMC card. We have just seen a brief demonstration of how the Zynq ADI SDR System Development Kit lets you quickly evaluate how Zynq-7000 All Programmable SoCs and the AD9361 Agile RF transceiver can address your cognitive radio and small cell wireless design challenges, including the need for higher signal processing performance, more software programmability, and lower power. The Zynq-7000 All Programmable SoC AD9361 software-defined radio systems development kit is now shipping. Order one today and start developing your next SDR application. To learn more about Zynq, go to xilinx.com/Zynq.